Hello, algebra students. Today we are learning about the Tower of Hanoi. Now I must tell you this is a made-up mathematical problem. It's going to sound like I'm teaching some type of ancient religion. I'm not. It's a problem that was made up by a mathematician, about 100 years ago. And what the Tower of Hanoi says that at the beginning of time, there were 3 diamond towers or spires, kind of like these black things here. And on one of the spires, 64 discs were stacked up. Here I have 5 discs. You see my 5 discs? Green one, yellow one, do. All right. And some priests at the very beginning of time began moving these discs. Now they were following some very important rules. But they began doing things like this. And as they moved them, each move corresponded to 1 second of existence. Now their goal was to have all 64 rings completely restacked on one of the other towers. And when they did that, they would complete all of time. What do I mean by that? That it means each move corresponds to a second of the universe's existence. And so once they're done stacking these rings, time stops. The universe collapses in on itself. Okay, you can see I've already got my biggest ring on the middle tower. Now I just got to figure out how to get them all stacked up onto the red one. So remember, this is only a story, but each move corresponded to a second of time. Very ancient math problem. Your job, and I'll let you know, I know college students who can't do this, who have difficulty doing this, you will be able to do it. Your job is going to be to figure out how many seconds or how many moves it would take to do the 64 rings that are talked about in the Tower of Hanoi problem. I'll have some models for you in class, but you're going to actually try to do it, okay? And then you're going to see if you can calculate how the length of the universe, from beginning to end, according to the story of the Tower of Hanoi. And once again, it's only a story, so please don't ask me, well, how much time do we have left or anything like that. Now, before you actually get to do it, you need to follow some important rules. The first rule is, I'm going to hide them from you. The first rule is you may only move 1 ring at a time. If you notice while I was moving my rings in the example, I only moved 1 ring at a time. The second rule is never put a larger ring on top of a smaller ring. I don't know if you noticed that, but I never put a smaller one on, or a larger one on top of a smaller. Okay, so that would mean I could not do this. The green is obviously smaller than the yellow. I can't do that. I know it looks like it's underneath because of the perception of the smartboard, but I can't do that. They must always be going from larger to smaller. I can do this. Let me see here. Like the green one isn't the next smallest compared to the orange, but it could be sitting on it. Or, for example, if the red one were here, I could have the green one on top of the red, but I could never have the green one, say, under the pink or under the orange. Okay? All right, so never have a larger ring on top of a smaller ring. The third rule is you may only have 3 piles. One thing kids always try to do is they get all the rings moved off of the first tower, which was this one, and then they like to go, well, what about if I do this? See, I only have 3 piles. No, this is actually 4 piles because the 3 towers count as a pile, even if there's nothing on them. Okay, now you're only going to have 1 tower, but the other 2 will be imaginary. But you could never have this situation. That's 4 piles. This is 4 piles. This is 3 piles. Okay, and then finally, the last rule is you may only move the ring on top. For example, you have your rings like this. I can't pull this pink one out like that. Okay, when you're actually doing it, you have to figure out a way. If you want the pink one to move, you've got to figure out a way to maneuver it out of there. Okay, so like so. All right, so your job when you come into class tomorrow, you'll have a partner and a tower to work with. You are to figure out how many moves it takes for your 5-tower ring. Now, this might seem like a totally abstract lesson, but it actually builds off of everything that we've been doing the past several days in terms of finding patterns. And I'll give you a hint that when you go to try to figure out how many moves it'll take for a 64-tower ring, you're definitely going to want to look for the pattern. So I think I'm going to leave it at that. I already solved it once. And I will say good night, everybody. Mr. Lawrence signing off.